What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to find out the pH of a buffer solution. So here we are dealing with propanoic acid. It says it has 4 parts. First part is gonna say what is the pH of 0.1 molar propanoic acid when Ka is 1.3 times 10 to the power of negative 5. It is just finding the pH of the acid. So I'm gonna write HC3H5O2 plus water is gonna produce, because it's a weak acid, that's why we have Ka, it's gonna be H3O plus C3H5O2 minus. So we have 0.1 in here, 0 and 0 right in the beginning. That's the initial. If we want to write the change and equilibrium, I stable, we have negative x plus x plus x. So it's going to be 0.1 minus x, x and x. Then I can say Ka, which is 1.3 times 10 to the power of negative 5 equals to x times x, x squared, divided by 0.1 minus x. So then we cancel x in here because it's negligible, and then we can say x squared equals to 0.1 times 1.3 times 10 to the power of negative 5. That will be 1.3 times 10 to the power of negative 6. So then when you find out square root, 1.3 times 10 to the power of negative 6, it will be 1.1 times 10 to the power of negative 3 molar. So that's the concentration of hydrogen. So pH will be negative log 1.1 times 10 to the power of negative 3, which will be negative log 1.1 times 10 to the power of negative 3. That will be 2.96. That's the pH of the acid. Now part B. It says find out the pH of 0.1 molar sodium propanoate, which is an ester. So we have NaC3H5O2. So that's the weak base. So that will be, that's dissociated. NaC3H5O2 dissociated completely to Na plus C3H5O2 minus. Then I can write C3H5O2 minus in aqueous solution plus H2O. It's going to give us HC3H5O2, which is propanoic acid, plus OH minus. Then I can say Kb equals to OH minus times HC3H5O2 divided by C3H5O2 minus. And here we can say Kb equals to 10 to the power of negative 14 divided by 1.3 times 10 to the power of negative 5. That's going to give us 7.7 times 10 to the power of negative 10. So this one is equal to 7.7 times 10 to the power of negative 10. OH and this guy, they have the same concentration. Why? Because if I write the I stable, this one is going to be 0.1, the initial concentration. This one is 0, 0, negative x, x and x. So 0.1 minus x, x and x. You sub it there, it's going to be x squared divided by 0.1 minus x. And we neglect this part. We can say x squared equals to 0.1 times 7.7 times 10 to the power of negative 10. X will be 8.8 times 10 to the power of negative 16. So POH will be negative log of x. which is going to be 8.94. Now part C, it says find out the pH of a pure H2O. We know the pH of the pure H2O or water, since proton equals to hydroxide is 10 to the power of -7, pH will be negative log 10 to the power of -7, which is going to be 7. Now let's do the last part, which is saying that a mixture containing 0.1 molar propanoic acid and 0.1 molar NaC3H5O2. I'm gonna write it in here. So this is the acid HC3H5O2 plus water. It's gonna give you H3O plus C3H5O2 minus. If we have the ice table, this one is 0.1, initially approximately 0, and we have 0.1 for this guy, negative x plus x plus x, so we have 0.1 minus x plus x, 0.1 plus x. So Ka, which is the acid dissociation, which is 1.3 times 10 to the power of -5, equals to x times 0.1 plus x divided by 0.1 minus x. If we neglect the x part, this one and this one cancel out, and 0.1 and 0.1 cancel out, I can say x equals to 1.3 times 10 to the power of -5. So pH will be negative log 1.3 times 10 to the power of -5. So pH will be 4.89. Or we can use Henderson-Hasselbalch equation. pH equals to pKa plus log of base divided by acid, which is 0.1 over 0.1. Make it 1 and it's 0, so pH equals to pKa, which is going to be equal to 4.89 as well.